Hello guys, and welcome back to a continuation of our physics answers. So, excuse me, if you remember from last time, when we left off, I'm gonna push you guys back a little bit. We left off on problem 7. We've covered 1 through 6 and the first round, and now we're gonna get on with 7, 8, and 9 in this video. And then we will do 7, 8, 9, and we will do 10, 11, and 13 because 12 is actually a replay of number 9. So let's get started. Okay, so number 7. All right, let's see. A proton traveling with a speed of 8.71 times 10 to the 5th meters per second collides elastically with a stationary proton. They stick together and then continue off at the same velocity. Determine the velocity. All right, so how many objects to begin with? 2, very good. And how many objects to end with? They stick together. That means they hit, and then we only have 1 object to end with. So we're looking at this equation, m1v1 plus m2v2 equals v m1 plus m2. All right, and we have a speed. There's one thing that's missing from this problem, and it's the mass of an electron. So I'm going to go onto my handy dandy phone here, and I'm going to take a look and look up the mass electron. Suri, what is the mass of a proton?
The answer I found is 1.008 atomic mass units.
Oh, we don't want it in mass units. We want it in kilograms. Suri, what is the mass of a proton in kilograms?
The answer I found is 1.008 atomic mass units.
Your teacher just got beat by Suri, so let's look it up. Bear with me, guys. What is the mass of a proton in kilograms? Ah, we got it, guys. So, the mass of a proton, ready for this? It's in scientific notation. So, 1.67 times 10 to the negative 27th. That is your mass. The first proton is traveling at a velocity of 8.71 times 10 to the 5th. 8.71 times 10 to the 5th. The second proton is stationary, so no matter what its mass is, we don't care because its velocity is 0. So that whole thing just drops out, right? Because this is all this, and this guy right here is 0. So that's okay. Equals, we're looking for the velocity, if they stick together, of the 2 masses. So what I'm going to do, this is the mass of a proton. I'm just going to multiply this by 2 to get the addition. Let's do that out right now. I know it might be a little difficult on your phones, but just look for that little exponential. I promise you, you will not have something like this on the quiz. It's just the process, but you're not going to have any big exponential scientific notation on your quiz. But since you've got me here, and I've got this here, and we can do it, let's do it together. 1.67 e to the negative 27th times 2 comes out to that right there. 3.34 times 10 to the negative 27th. All right, so we do this math out, we multiply this, and we get, oopsies, just dropped my paper. We multiply this out, so let's do this. I'll do this for you. 1.67 e to the negative 27th times 8.71 e to the 5th. This comes out to be 1.45 times 10 to the negative 21st equals v times 3.34 times 10 to the negative 27th. Now we will simply divide 3.34 times 10 to the negative 27th, 3.34 times 10 to the negative 27th, and we get a velocity of the two protons sticking together, and they are traveling at 435,500 meters per second. Oopsies. 435,500 meters per second. It's pretty fast. Okay? Promise you, you won't have anything with big exponentials on your test. I promise. But it's still the method, and it's still the practice of going through it. So, if there are no questions, yeah, you there. Is this going to be on our test? No. Don't worry. Nothing with big exponentials like this will not be on your test, but good question. Let's move on, guys. All right. So let's take a look at number 8 now. If 10 newtons of force is applied to a 2 kilogram cart for 5.5 seconds. So we have 10 newtons is our force. This is number 8. And it is applied to a 2 kilogram cart. That's a mass. And it's for 0.5 seconds. That's our time. Let's see, what is the impulse? So we want to find impulse. Our impulse, if the cart was originally traveling at a velocity of 10 meters per second, what is the new velocity? Okay, this is a good one. This is involving our definition of impulse and using the multiple equations to figure it out. So we want to find the new velocity as well. So we're looking for those two things. All right, first, let's write our impulse equation down. Impulse equals Ft, but it also equals a change in momentum. Okay, first thing we want to do is find that impulse. Impulse equals force 10 times our t, 0.5. 10 times 0.5 is what? Just 5. 10 times a half is 5. 5 Newton seconds. There's our impulse. So you just found that one. Check. Done. Now we have to find out if it was originally traveling at 10 meters per second, what is the new velocity? All right. We know that impulse is F times t. We also know that impulse is the change in momentum. So let's put all that together. Change in momentum is really the final momentum. Oh, sorry, let me write that in a different way. Is really the final momentum minus the initial momentum, right? It's the mv final minus the mv initial. And I know you have seen this before, m delta v, right? Which is just final minus initial. So let's solve this. The mass is 2 kilograms. The final velocity is what we're looking for. The mass is 2 kilograms, and the initial velocity, it said it was traveling at 10. Now you're saying, well, Mr. F, what is this equal to? What is this value right here? Right? What is this value? Well, we said it's the change in momentum, right? Change in momentum equals down, write it down. What's the change in momentum? Well, we know the change in momentum is really F times t, is really impulse. You just solve for that. You said it was 5. So we're looking for the same thing, but we're wording it differently. 5 equals 2v minus 20. Add the 20, add the 20. 25 equals 2v divided by 2 divided by 2. V comes out to be 12.5 meters per second. So based on an impulse of 5, the cart went from 10 meters per second to 12.5 meters per second. So that should be your answer. Okay, guys? All right, so we did 7, we did 8. Let's do number 9. 9's a big one. We're gonna get through it. Hopefully you guys got all that before I erased it. Oh, what am I saying? You could just hit pause. All right, number 9, ready? 2 billiard balls of mass 160 grams each collide head on. Ball A has an initial velocity of 11 meters per second. After the collision, ball A and ball B both continue in the original direction of A. A travels at 4 meters per second and B travels at 3 meters per second. What was the initial velocity? Okay. I am actually just comparing the two. Okay, so yes. So 9 and 12 are the exact same thing. So that's what we're going to do. 9 and number 12 are the exact same number. So let's take a look at this. So we've got 2 billiard balls. So one is A and one is B. So they collide and they hit head on. So A is going this way, B is going this way. Notice right away, opposite directions. What does that mean? One has to be a plus, one has to be a minus. Convention says this way is plus, so let's make it. So this way is our plus, that way is our minus. So they're hitting head on. Boom, there's a collision, right? Now what happens? Well, it says after the collision, ball A and B both continue in the original direction of A. So now A is still going this way, and B is now going this way. So they both carry the positive now. All right. A travels at 4 and B travels at 3 meters per second. What's the initial velocity of B? So we're looking for this initial velocity. How many objects before the collision? 2. M1 V1 plus M2 V2. How many objects after the collision? 2, very good. M1 V1 plus M2 V2. Let's fill in our information. So the billiard balls have 160 grams each, so 160, right? The velocity of A originally was 11 plus, wait, what's that, guys? You're trying to tell me something, but I can't hear you through the camera. Hold on, let me try and listen closely. Hold on. I'm picking up something here. Something about my math. I did something wrong? Come on, guys, that's crazy. I did something wrong. I did do something wrong. You caught me. You pointed it out. Good job. Thank you. I did something wrong. This 160 here is in grams. We don't do our math in grams, do we? We do it in kilograms. And when we have kilograms, we need to move that decimal 3 places. So this should be a 0.160. For all of you who are screaming at the computer, I appreciate that. I thank you. Good catch. All right, let's keep going. 0.160 times 11. 0.160. We're looking for the initial velocity. That's what we're trying to solve for. Equals, let's see, the mass. It is still 0.160. Now it says ball A is traveling in the original direction at 4. And ball B still has the same mass, is traveling at 3 meters per second. So let's go ahead and get this math done and out of the way. 0.160 times 11 comes out to be 1.76 plus, I made another mistake. Can you tell me where? Good. Well, the velocity you know is going to be a negative. So let's leave this as a plus. This should automatically go out to be a negative. Let's just see for a second. 0.160 v equals 0.160 times 4.64 plus 0.160 times 3.48. Okay, let's condense this. 1.76 plus 0.160 v. We cannot combine these because this is a number, this is a term with a v. We cannot combine these, cannot combine them. Equals, but we can combine these because there's no v, right? 8, 9, 10, 11, 12, 2, 7, 8, 9, 10, 11, 1.1. Now we can subtract, we can subtract this, and here's where we will get that negative. So everything will work out fine. I promise you that. We get 0.160 v equals, right? Negative 0.64. We need to divide, and we get a velocity that's coming out to be negative. We know that's right because it was a negative opposite direction anyway. 0.64 divided by 0.160 is 4. Look how nicely that works out. Negative 4 meters per second. We found out that this ball is moving at negative 4 meters per second. And intuitively, think about it. This makes sense because this ball was traveling at 11. This one was traveling at 4. It's going to overpower it, and they're both going to continue to travel up. So I hope this has helped you. I hope you've enjoyed it. I thank you for catching my mistake before. So keep up the good work, and I will see you guys with the last 3 questions in our last video of the answers for your test study guide. All right, guys, take care. See you in a little bit. Bye.